All right, today we're diving into a really cool paper that could fundamentally change how we deal with real-time data. It's called PatternStudio, a neuro-symbolic framework for dynamic and high-throughput complex event processing. It's by Jesus Rosa-Bilbao from the UCAS Software Engineering Research Group at the University of Cadiz, and it was published in MDPI. Now, I know that's a mouthful, but the core idea here is a potential game changer, especially for the whole world of IoT.
Okay, so here's our game plan. First, we're going to dig into the big problem, the data processing dilemma that this whole thing is trying to solve. Then, we'll get into the really clever part, the neuro-symbolic solution. After that, we'll peek under the hood at the PatternStudio engine itself, see how it holds up under pressure, and finally, we'll talk about why this is such a big deal for the Internet of Things.
All right, let's set the stage. What's the core problem we're even talking about here? Well, imagine these massive, never-ending rivers of data pouring in from all our smart devices, from the Internet of Things. Trying to manage that puts you in a tough spot, a constant tug of war between having a really powerful system and one that people can actually, use.
I mean, we are literally surrounded by smart devices, right? And they're all just constantly chattering, streaming data. To find the important signals in all that noise, in real time, we use something called complex event processing, or CP for short. Just think of it like a detective sifting through a flood of clues to find the one meaningful pattern. It's absolutely essential for IoT, but as this paper points out, the current tools have some pretty major flaws holding them back.
And this slide just lays out the four big headaches perfectly. First, you've got the authoring barrier. Basically, if you're not a programmer, good luck writing the rules. Then there's operational rigidity, which is just painful. It means you have to take the whole system offline just to make a small change. Next is the explainability gap. This is a huge one with AI systems becoming these black boxes, where you have no idea why they made a decision. And last, you have this deployment tension, that constant battle between making a system flexible and making it fast.
So the big question is, how on earth do you solve all four of those problems at the same time? Well, this is where the paper's big idea comes in, a neuro-symbolic approach. It's all about combining the best of both worlds. It's like pairing a creative, flexible artist, that's the AI, with a super logical, by-the-book engineer. That's your traditional system. And the paper uses this fantastic analogy from psychology, the idea of two systems of thinking. You've got system one, which is your fast, intuitive gut reaction. That's the neural AI. It's amazing with language, super flexible, but it can mess up, it can hallucinate. Then you have system two, which is your slow, deliberate, logical thinking. That's a symbolic system. It follows the rules perfectly, but it's totally rigid. The real magic of PatternStudio is that it figures out how to make these two completely different ways of thinking collaborate. And here's the crucial part, the key to the whole thing. The AI doesn't just get to run wild. Think of it like this. The AI's a brilliant but sometimes eccentric translator. It takes a simple request from a person and turns it into a technical blueprint. But, and this is a big but, before that blueprint goes anywhere, a super strict deterministic factory manager comes in, inspects every single detail, and only if it's perfect does it get approved for the production line. This is how you get all the power of natural language without losing an ounce of reliability.
Okay, so that's the high-level idea. That's the what. Now, let's pop the hood and see how this thing actually works. Let's look inside the PatternStudio engine. The whole process is this really elegant four-step dance. It all starts with intent. A domain expert, not a coder, just writes what they need in plain English. Something like, hey, send an alert if the temperature goes over 75 degrees for a full minute. Simple. Step two is translation. An LLM takes that English sentence and translates it into a perfectly structured, machine-readable format. Now, step three is where the real magic happens. Injection. That new rule gets injected into the system while it's still running. No downtime at all. And finally, execution. A super reliable engine, in this case Apache Flink, takes that rule and puts it to work on the live data stream. It's just a beautiful, seamless flow from a human thought to a machine action.
Now, this all sounds fantastic on paper, right? But the real question is, how does it hold up in the real world? Does it crumble under pressure? So the researchers did exactly what you'd hope. They put it through a serious stress test, and not on some supercomputer, but on the kind of everyday hardware you'd find out in the field. And honestly, the results are pretty darn impressive. At its peak, the system was churning through almost 48,000 events every single second. Now, to put that into perspective, that is a ton of data for just one machine to handle, especially a system that's built to be this dynamic and easy to change on the fly. But this is where things get really interesting and kind of weird. You'd think that the more rules you add, the slower the system gets, right? That just makes sense. But nope, look at this. The performance actually gets better as you add more rules, climbing and climbing until it hits this perfect sweet spot at around 250 rules. Only then does it start to drop off. So why does that happen? Well, this next graph gives us the answer. See the CPU line? It just climbs steadily until, boom, right around that 250 rule mark, it hits 100% and flatlines. The processor is completely maxed out. That's our bottleneck. But look at the memory. It's almost perfectly flat. It stays stable the whole time, which is fantastic news. It tells you the system is really well engineered and isn't going to crash on you because of a memory leak. Okay, let's step back and look at the big picture. We've seen the theory, we've seen the performance. So what? What does this all actually mean for the world of IoT where change is the only constant? Well, it means PatternStudio hits every single one of those 4 big problems we talked about at the beginning head on. It empowers experts by letting them use plain English instead of code. It delivers continuous operation with those amazing zero-downtime updates. It stays auditable and reliable because the AI has clear guardrails. And it's edge-ready, meaning it's efficient enough to run right where the action is. It's just a really smart, holistic solution to a very thorny problem.
You know, this whole thing makes you think way beyond just IoT. It really leaves us with this massive question for the future. If AI is getting this good at translating what we want into what machines do, what other rigid code-based systems are ready to be disrupted? Where else can we rip out inflexible code and replace it with these kinds of flexible, on-the-fly instructions? And that's our look at PatternStudio. Seriously, if this stuff interests you at all, I highly recommend you check out the original paper. Again, it's called PatternStudio, a Neuro-Symbolic Framework for Dynamic and High-Throughput Complex Event Processing by Jesus Rosa Bilbao. You can find the DOI in the article. It's a really great piece of work that opens up some exciting new possibilities. Thanks for tuning in.